So let's review of what's the exponential function that we have last time. So function f of x equal to a to the x, or we write it y equal to a to the x, or a, I said it is greater than 0, not equal to 1, but in general, exponential functions are function where a is greater than 0, okay? So I want to add a page here. And let's try this. All right, so exponential function, start with that. Y equal to a to the x, where a is greater than 1. So you can think as a equal to 2, something like 2 to the x, okay, 2 to the x. Let's draw this. Okay, draw this. When x equal to 0, okay, 2 to the 0, which is equal to 1. So I start with here, 2 to 0, x equal to 1, right here, and 2 to the power 1, which is equal to 2. Here's the 1. And when it's a negative 1, okay, 2 to the power negative 1, we know it's negative exponent, that is 1/2. So I want to connect those dots here. So that's smaller and smaller. It gets bigger and bigger. So when you connect those dots, we have graph like this. Okay, so that's the first page. So one picture shows 1,000 words. Let's modify it from here, analyze it. So from this guy, okay, when x gets a negative large number, your function a to the negative large number, we know that is a 0. For this guy, let me call forever like that, a to the positive infinitive, which is a positive large number, we have a positive infinitive. Not only that, it's because of this magic number here. We have a to the power 0, which is equal to 1. So it's more likely these guys are important. Of course, a to the x is always greater than 0. It's because above x-axis. So we are all okay with this. So we do have some transformations. So transformations that we have, something like a to the negative x, negative a to the x that we have. Okay, of course, there are more transformations that is on page, is that page 3? Available. Okay, so we could have a to the x, and then you're adding some number, subtracting some number, or something like that, or a to the x, and then you add a number. So it's a transformation, it's a shift up and down, okay? So we do have exercise from last time. And one example of exponential function that is compound interest. A equal to p times 1 plus r over n to the power nt. And we use the word parent, p, a, r, n, t. Okay. P is the beginning amount, principal. A is accumulate balance, account balance. R is a rate. N is number of interest paid per year. And T is number of years we invest the money or deposit it. Okay, on page 4, we have example 4. On page 4, we have done this last class. I want to revisit this once more, okay? I want to revisit this once more. So go back to the page 4. There's my page. This is the page. Okay. So formula for compound interest is given by a equal to p times 1 plus r over n to the power nt. Let's look at this example once more. So p, a, r, n, t. P equal to 10,000. A we want to know how much should it be. The rate is 0.0325. How often we get paid? It says a monthly compounding, so it's a 12. And how many years? It's 5 years. Okay, so we put this together into the formula. A equal to P 10,000 times 1 plus 0.0325 over 12 to the power 12 times 5, which is a 60. Let's get the number. Divided by 12 to the power 60. Okay, so 11761.90. This would be the balance after 5 years. Now, so some of us get confused. It says annual rate. So 3.25 all together as it's 1 year, 3.25%. Okay, not just monthly. So every month is divided by 12. I want to change this wording a little bit. So instead of saying monthly, okay, instead of saying monthly, if I change this to weekly, okay, weekly. So everything is the same except this guy, okay? So every week we get the interest. So there are 52 weeks a year, okay? And I want to see the balance. So everything is the same. The only difference is weekly payment. So A equal to 10,000, 1 plus 0.0325 over 52 to the power 52 times 5, which is 260. Let's see. 10,000, 1 plus 0.0325 over 52 to the power 260. Okay. 11763.89. I want you to look at these two numbers together, okay, and see the difference. So one is this, and the other is this. I did not change this, okay? It's still 3.25. The only difference is one account to give interest every month, the other account to give interest every week. And you see the amount end of 5 years, your account balance is slightly higher than it is. Why is that?
Would it be because it compounds more?
It's because it compounds more. It's compound interest. Another way to say interest is on interest. So even though it is a 3.25% contributed to monthly or weekly, so every week we get interest. So first week we get interest on original. Second week we get original plus the first week interest on interest. And the third week we get original amount interest plus interest on first week interest and interest on second week of interest, and then from the original. And then they keep adding on this. So you get more interest on interest. So ideally, if I said instead of monthly, instead of weekly, if it is a daily, okay, I expect to get more money, okay, A equal to higher amount. If I said hourly, every hour I get interest, I expect a higher amount. Do you understand this? So amount gets higher and higher. That's compound interest. So how much can it be higher? Can it be infinitive? The answer is no. We are going to have something special, okay? So keep in mind that this is one of those applications of general exponential function. Any question on general exponential function?
I have a question about the homework because I was doing it with
Okay.
a fellow classmate of mine right after
Okay.
class the other day. And
Which question?
let me go to my notes
Was
to
it
find it.
is a workbook question or my open math?
It's a workbook.